Most known black holes are either extremely massive, like the supermassive black holes at the cores of large galaxies, or relatively lightweight, with a mass of under 100 times that of the Sun. However, intermediate mass black holes, or IMBHs, are rare and considered the elusive missing links in black hole evolution. Intermediate mass black holes are scarce, making them a fascinating subject for astronomers. These black holes bridge the gap between the smaller stellar mass black holes and the colossal supermassive black holes. Their rarity has made them difficult to study, and only a few candidates have been identified to date. Understanding IMBHs could provide crucial insights into the formation and growth of black holes, as well as the dynamics of the galaxies and star clusters they inhabit. The discovery of an IMBH in Omega Centauri, a massive globular star cluster, could be a significant breakthrough in this field of study. An international team of astronomers utilized over 500 images from NASA's Hubble Space Telescope, spanning 2 decades of observations, to search for evidence of an intermediate mass black hole in Omega Centauri. By tracking the motion of 7 fast-moving stars in the innermost region of the cluster, they gathered compelling evidence of a gravitational pull from an IMBH. Omega Centauri, consisting of roughly 10 million stars, is about 10 times as massive as other large globular clusters, almost as massive as a small galaxy. The astronomers created an extensive catalog of star motions, measuring the velocities of 1.4 million stars from Hubble images, initially intended for instrument calibration. "We discovered 7 stars that should not be there," explained Maximilian Häberle of the Max Planck Institute for Astronomy in Germany, who led the investigation. "They are moving so fast that they would escape the cluster and never come back. The most likely explanation is that a very massive object is gravitationally pulling on these stars and keeping them close to the center. The only object that can be so massive is a black hole, with a mass at least 8,200 times that of our Sun." This discovery provides the most direct evidence so far of an IMBH in Omega Centauri, adding to the few known black holes with similar mass. The presence of an IMBH in Omega Centauri raises several intriguing questions for scientists. Are IMBHs common, and do they serve as seeds for the growth of supermassive black holes? How do these intermediate mass black holes form, and are dense star clusters their preferred habitats? The answers to these questions could significantly advance our understanding of black hole evolution and the dynamics of star clusters. The discovery also suggests that IMBHs might be more prevalent than previously thought, potentially altering our perception of black hole distribution in the universe. Omega Centauri is a fascinating celestial object with a rich history. It was first listed in Ptolemy's catalog nearly 2,000 years ago as a single star. Edmund Halley reported it as a nebula in 1677, and in the 1830s, English astronomer John Herschel recognized it as a globular cluster. Located just above the plane of the Milky Way, Omega Centauri is visible to the naked eye from Earth and appears almost as large as the full moon when viewed from a dark rural area. It remains a favorite target for stargazers in the southern hemisphere. If confirmed, the candidate black hole in Omega Centauri, located 17,700 light-years from Earth, would be closer to us than the 4.3 million solar mass black hole at the center of the Milky Way, which is 26,000 light-years away. This discovery is exciting because it provides a rare opportunity to study an intermediate mass black hole in our cosmic neighborhood. As Nadine Neumayer of the Max Planck Institute for Astronomy stated, "This is the most direct evidence so far of an IMBH in Omega Centauri." The findings could pave the way for future research and deepen our understanding of black hole formation and evolution.